Hi, in today's lesson we're going to be talking about convection. I told you before now, convection is a transfer of thermal energy. The transfer of thermal energy by the movement of particles. By the movement of particles. The transfer of thermal energy, excuse me, the transfer of thermal energy by the movement of the particles by the movement of liquid or a gas, or you say by the movement of the particles in liquid or in a gas. Now we need to know that in the first lesson we talk about conduction. In conduction, there's a transfer of heat energy or thermal energy from a solid material to another solid material. That's conduction. Conduction involves transfer of heat from solid to another solid. While convection is a transfer of heat from liquid to liquid or gas to gas. So the movement of particles, the transfer of thermal energy by the movement of particles in liquid or gas is called convection. And now let's go to the slide I want to use for our class today. Excuse me. Today we're going to talk about another type of heat transfer, which we know as radiation. Excuse me. Okay. Now, let me take my time to talk about this again. I told you in the last lesson that whenever you're using a freezer at home, and the reason why the way we make the freezer is in a way that does it transfer. Where is the freezer compartment put in the fridge? This is where the freezer compartment is put in the fridge. It's put in this location. And the reason why it's put here is because it is put at the top, because cool air sinks. The cool air will have to sink down, so it cools the food on the way down. So as the cool air is moving downwards, it's cooling the food at the bottom level. So that's the reason we put the freezer on the top side, so that when the cool air is coming down, it cools the food on its way down. And the warm air will have to rise back to the top side. So this continues to occur every time in the freezer, and that's the reason all the food is being refrigerated evenly. The same time. It is warmer at the bottom, so that the warmer air rises and the convection current is set up there. So now we will need to know the other type of the other type we need to talk about now. Excuse me, please. Okay. Now, let's move to the next stage, the third method of heat transfer. The third method of heat transfer is called radiation. How does heat energy get from the sun to the earth? This is a good question. You might be thinking about the distance of the sun from us here. And before we know it, it gets hot on the earth's surface. And the sun is far away from us. why is it so fast for the sun to send its hotness down to the earth's surface? There are no particles between the sun and the earth, so it cannot travel by conduction and convection. Let me remind you again. Conduction means there must be the particles, there must be the transfer of heat from a solid particle to another solid particle. That is to say, a solid material will have to transfer heat to another solid material through the process of conduction. And while in convection, there's heat transfer from a liquid material to another liquid material, or a gas material to another gas material. And now in the case with radiation, it has to be through some other means. And now let's talk about radiation now. Radiation travels in a straight line. Yes, it travels in a straight line. Radiation can travel through a vacuum. Yes, it travels through a vacuum. Radiation requires particles to travel. No, it doesn't require particles to travel at all. Radiation travels at the speed of light. Yes, of course. And that's the reason you get the heat energy or the hotness of the sun as fast as possible. So the next thing we talk about now is the emission of experiment. We want to talk about the way in which hotness, or we want to talk about the way in which we use the color of a material to know how we send heat energy away or absorb heat energy. 4 containers were filled with warm water. Which container would have the warmest water half to 10 minutes? The first material is shiny, dull metal, dull black, and shiny black. Now the shiny metal containers will be the warmest after 10 minutes because its shiny surface reflects heat radiation back into the container, so less is lost. The dull black container will be the coolest because it is the best at emitting heat radiation. Now look at this. So the dull material here has a tendency to move away, has a tendency because to emit heat energy from radiation, and that's the reason we're gonna say it's gonna be the coolest material, and this is gonna be the coolest material because it has a tendency to emit heat energy by radiation. So the shiny metal, this is the shiny metal here. This will sorry, let me pick more colorful. So now this is gonna be the container here will be the warmest after 10 minutes, and the reason why it's going to be the warmest is because it has a tendency, it has a shiny surface, and the shiny surface is going to reflect back radiation from the wall into the container. Now when the heat strikes the container, there will be a kind of reflection back to the wall, to the container, so less heat is lost. And the dull black here, this container will be the coolest because it best at emitting heat through radiation. And now the next one we need to talk about here is absorption experiment. 4 containers were placed equidistant from a heater, means they're placed at the same distance from a heater. Which container will have the warmest water after 10 minutes? The dull black container will be the warmest after 10 minutes. The dull black here will be the warmest after 10 minutes. Its surface absorbs heat radiation the best. Now the shiny metal container will be the coolest because it is the poorest at absorbing heat radiation. And this is the reason today you find people used to buy cars which has a shiny metal surface, and guys don't use a black car much in Saudi because the environment is so hot. So it to be so hot for them to use a black material because it absorbs more heat radiation, while the shiny metal material will have to reflect back the heat for radiation. And now we have some questions here for you, but we're going to continue from where we start in the next lesson. Thank you for listening. I will appreciate it.